A three-phase Y connected load is connected to a balanced three-phase Y connected source. Oh, that's a lot of connected. So the line voltage of the source is 480 volt. You have been given a line impedance of 3 plus J4 ohms and load impedance. So the question here is asking for the magnitude of the line current. So first and foremost, like any other circuit analysis three-phase problem, if you're not given the circuit, draw it yourself to be able to visualize what's going on. So here we have a Y connected load and a Y connected source. I'm pretty bad at drawing, but I just make sure you get the point. Ooh, that's bad. Sorry. Oh man, that's terrible. So this is my Y connected source, and I have a line impedance here given as 3 plus J4. And then I also have a load impedance connected load connected Y. That's pretty bad drawing, but you get the point. So I have a 30 plus 20 J20 ohm here. So now, this is 480 volt, the line voltage. So now the question is asking for magnitude of the line. So this line over here, magnitude of the line current. So let's call this IA if we want to, but whatever. We can call it I line or IA over IB, whatever. So we have to consider this, we have to solve this per phase, right? So we cannot use the entire system and solve it. So let me put this, solve it using a per phase. So we have to consider this per phase alpha. Let's say we're just considering phase alpha, and if we are doing that, that means this voltage is not going to be used because this is a system voltage, this is a line voltage. So we have to use a phase voltage in order to do that, because this is Y connected. Your phase voltage, remember, is your V line over square root of 3, and there is a 30-degree lagging for Y connected, because for Y connected voltages, your line and your phase are not equal. They are square root of 3 and minus 30 degree apart. In a delta connected source or delta connected period, your phase voltages and your line voltages are equal. So don't forget the minus 30 degree here. Sometimes people forget that, but it's really, really important in your calculation. It makes a difference. So that's what we have. So this is my known. So therefore, if I'm going to consider only one, this phase right here, phase alpha, then the phase voltage is then equal to 480 volt divided by square root of 3 minus 30 degrees. So this is equal to 277 minus 30 degrees. So we have a voltage here of 277 that we just had calculated. And just looking at this circuit right here, right, this is just, from here on, is just simple circuit analysis, right? So we have a voltage and we have two impedances in series. So to calculate this current right here, we just add the two impedances in series, and then V equals IR, right? So I, the current, but IA for that phase would be the voltage that we just had found divided by the series impedance. So this would be 3 plus J4. They're in series, so 30 plus J20. So this would be 277. From here it's just calculation from your this is 33 plus J24. Plug it in your calculator. Let me do it now. I have 277 minus 30 degrees divided by 33 plus 24, Juliet, 24. I have equals to 678 with an angle of minus 66 degrees. So the line current is equal to, the magnitude is equal to 678 amp. And that's it. So after I solve every problem, I kind of give you some the keywords or key points to remember. So in this case, one thing to remember is the fact that you have a Y source. So in that case, your phase voltage and your line voltage are not equal. They are square root of 3 and minus 30 degree apart, basically. So your line voltage, like I said earlier in another video, your line voltage is always bigger than your phase voltage. So if you're wondering whether or not you got to divide or you got to multiply by square root of 3, because that kind of can get confusing, remember that your line voltage is higher, is bigger than your phase voltage, because the line voltage is your entire system voltage. And your phase is just looking at phase alpha, phase bravo, or phase Charlie, alpha, A, B, C. So for Y connected, your phase and your line are not equal. They are minus 30 degrees apart and then square root of 3 apart. So once you understand that, because you got to solve it per phase, once you understand that, then you can go ahead and apply your standard circuit analysis skills or whatever to solve the problem. Fairly straightforward as well.